Voltage is the push that causes the electrons to move around the circuit, and current is the movement of the electrons around the circuit. We can measure voltage with a voltmeter, which needs to go across a component, and we can measure current with an ammeter, which needs to be in line with the flow of electricity. Now let's talk quantitatively. Remember, current is a flow of electrons, negatively charged particles. We measure charge in units called coulombs. The charge on one electron is very small, but if we have many of them, around 6 million, we will have a total charge of 1 coulomb. If this 1 coulomb of charge passes a point in our circuit in 1 second, we say we have 1 amp of current. Current is charge Q divided by time T. A quick example calculation. 0.5 coulombs of charge flow past a point in 5 seconds. What's the current? Well, current is charge Q divided by time T. That's 0.5 coulombs divided by 5 seconds, giving us a current of 0.1 amps. Now for voltage. This is the amount of energy transferred to each coulomb of electrons. If a cell gives 1 joule of energy to 1 coulomb of electrons, then the cell's voltage is 1 volt. Voltage is energy E per coulomb Q. One final example calculation. A cell has a voltage of 3 volts. How much energy is transferred to half a coulomb of electrons? Pause the video and have a go at this one yourself. Let's check your answer. If voltage is energy divided by charge, we can rearrange to energy equals voltage times charge. That's 3 volts times 0.5 coulombs, giving us 1.5 joules of energy.